In this example, we've got two charges. Again, we're given both magnitudes of both charges. A is positive, it's a little positive here, B is negative. At what point is the electric field intensity around these guys 0? What we're talking about here is we want to know, like in the last question, we were talking about the sum of E. I want to know where is that equal to 0. So A produces an E field, B produces an E field, electric field. I want to know when I add them together to find the net field, where is it going to be 0? That's what I'm looking for. Let's talk about just kind of locations for a quick second. Remember, if this guy is positive, E fields always point away from positives. Okay, so E field due to A is going to point this way. E field due to A is going to point away this way. If I look at, and same way, up here it's going to point up, down here is going to point down. If I look at the E field from this guy, E fields always point in towards negatives. So E field is going to point this way towards B. E field is going to point this way towards B. Okay, so these two E fields are not going to add to 0. They're both in the same direction. Even if one of them is 0, the other one's not. And in this case, actually, neither is 0. They're never going to add to 0. So we need to start looking outside. So over here, I said the E field due to A points away from positives. Remember, it points towards negatives. Now they're in opposite direction. Depending on what those numbers are, if they're the same number but opposite direction, then they could add to 0. That's good. Similarly over here, E field from this guy is going to point that way, away from A. It could also add to 0. Okay, so it's on either side. It's definitely not in between them. It's somewhere on the outside where these two E fields add to 0. The other thing we can look at is the magnitude of the charge. Because this is smaller, it's got to be on the side of the smaller charge. Because this guy is a much bigger charge, it has to have that bigger distance in order that those two can cancel out. And so it's going to be over here somewhere. We're going to work it out and we'll find out the answer is over there, but just kind of going into this, we're going to know the answer is somewhere out over here, and that's what I'm looking for. So it can't be here. It actually can't be here either. What we're going to do when we do this is this exact thing. I'm going to look for where are they in opposite directions over here, then also where are they the same magnitude. Okay, so if I was to bring this guy over here, you could say EA is equal to the negative of EB for sure. Remember that negative sign just shows those directions. When I use these equations though, I'm using magnitude only. I'm not going to sub in the positive and negative signs. So when I do this, I'm going to do magnitude only, which means I'm going to forget about that negative sign right there. So I'll come back and talk about these locations again, but what I want to know is where is the magnitude of those, where is the magnitude of those the same? EA is K QA over RA squared. This one, K QA QB over RB squared. We could actually just cancel those things out. We know the K value 9 times 10 to the 9. It's the same on both sides. We can just cancel it out. We don't need it. Okay, so QA, we know charge A is 3.6 times 10 to the negative 7. RA, I don't know what it is. Let's go ahead and just kind of draw something over here. Let's just say, let's let this be RA. Okay, so I'm going to leave this as RA squared. What that means though, QB magnitude only, okay, so no negative. What that means then, RB is actually 15 centimeters plus RA. Okay, so we could write this as RB. Maybe I'll write it up here. RB, just note, is 15 centimeters plus RA. Okay, so I'm going to write it like this. RA plus 0.15 meters. That whole thing, remember, the whole RB is squared. Okay, so if I sub that in for RB, I still need to square that entire thing. Now I can just do some cross multiplying. Math teachers always hate that, but cross multiplying it is 3.6 times 10 to the minus 7 right there, times, this is going to be RA plus 0.15 squared. This RA is going to come up over here, so 8.1 times 10 to the minus 7 RA squared. All right, sometimes people get weirded out when I do this, but you can do this. Remember, this is just a number times this RA squared. This number right here, this 10 to the minus 7 is on both sides. I can actually cancel that. That's going to make my math just a little bit easier. If you don't like that, you don't have to do this, but it will make my life just a little bit easier as I do this. This is 3.6. Okay, when we look at this bracket, don't forget, we have to FOIL this out. This is like, you know, when you've got a bracket and another bracket, what is it? RA plus 0.15, RA plus 0.15. You're doing first, you're doing inside, outside, and last. Okay, so as we go through that, it's going to be RA squared, 0.15 RA, another 0.15 RA, 0.3 RA, and then 0.15 squared is 0.0225, I think that says. 0.0225, yeah. On this side, 8.1 RA squared. Okay, I'm running low on room. I'm going to slide up just a little bit. Hopefully you can still see this. Now we could multiply the 3.6 into the RA squared and into this number, or you could just divide both sides by it. I kind of like that. Let's divide this side. So on this side, we've got RA squared plus 0.3, RA plus 0.0225, 8.1 over 3.6, 2.25 RA squared. Now what I'm going to do is bring everything to the same side. Let's take everything over here. So I'm actually going to get 0 equals 1.25 RA squared minus 0.3 RA, minus, let's fix that, minus 0.0225. We're going to use the quadratic equation. Okay, so let's come up over here, use quadratic equation, or is it the quadratic formula? I never remember. We're going to get two answers out of this thing. We're either going to get 0.3 meters, or we're going to get RA is equal to negative 0.06 meters. All right, so this comes back to our whole discussion of where these locations are. So looking at those locations, let's see if I slide this down a little. Looking at these locations, we've already agreed we can't be talking about this one. Here, the two numbers, maybe they're equal there, which they would be. They'll be equal here, but they're in the same direction. They're not going to cancel. Whereas out here, they are going to cancel. When I'm looking at this, I'm measuring from here going that direction. This negative 0.06 is actually that location, but this is my rejected answer. So I'm going to reject this one, reject this answer. But what does this answer mean? This answer, it doesn't answer this question, but the equations, remember when I did this as if they were magnitudes, no negatives. If I was looking for example, if this was positive and this was positive, or this was negative and this was negative, then it would actually happen right here. This answer is if they were the same sign. So I'll say this, correct if QA and QB have same sign. Okay, this is the same sign answer. That's not the case. I've got opposite signs, positive, negative. It's not this guy. Okay, so I'm going to reject this one. This is the answer that I'm looking for. At what point is electric field intensity 0? Right here, 0.3 meters from charge A. So this answer is the opposite sign answer. Opposite sign. So let's say QA and QB have opposite sign. That's a better way to say it, which they do in this case. That's our answer. 0.3 meters to left of A. Let's kind of squeeze that in there. And that's how we would do this question.